Okay, so imagine grabbing the USB port on your laptop, stretching it across an entire city grid, and, never losing a single packet of data. Welcome to this deep dive.
Yeah, it honestly sounds like science fiction, but that is exactly what we're looking at today.
Right, today we're tearing into a technical catalog page from HDTVSupply. The target is a highly specialized piece of hardware. It's the Smart-AVI USB 2.0 over fiber transmitter.
Which is quite a mouthful.
It really is. But our mission here is to figure out why someone drops, like, nearly $600 just to send a standard USB signal miles away.
Well, it looks like this unassuming, maybe 1.5-pound metal box,
Right.
right? But the engineering inside solves a massive logistical nightmare. I mean, we usually think of peripheral limits in terms of a desk.
Or maybe a standard conference room, yeah.
Exactly. But this specific device pushes a standard USB 2.0 connection out to an astounding 10 kilometers.
Wait, 10 kilometers, that's about 6.2 miles. But if we're just trying to get a video or control signal across a massive commercial space, why rely on a direct USB fiber extension at all?
You mean instead of standard networking?
Yeah, like most modern IT setups would just route an HDMI or USB signal over an existing Ethernet network and just call it a day.
Right. Networked extenders are super common, but they inherently introduce latency and compression. So when you are managing complex real-time control systems,
Like interactive touch screens or security scanners.
exactly, or, high-speed PTZ cameras in a stadium, you need the zero latency, uncompressed data stream that only a direct USB connection provides.
Because Ethernet packets have to be constantly encoded, routed, and decoded.
You got it. Direct fiber simply passes the raw optical pulse instantaneously.
Okay, that makes total sense for that kind of application. But looking at the spec sheet here, it lists two very different ranges for this direct connection.
Yeah, the two different fiber modes.
Right, like it says multi-mode at 500 feet and then single mode out to that 10-kilometer mark.
Yeah, that is a huge gap in distance.
It is. So what is fundamentally changing inside the cable to get that massive jump?
Well, it really comes down to the light source and the core diameter of the fiber itself. So multi-mode fiber uses an LED light that bounces around inside a wider core.
Okay.
And that bouncing, which is known as modal dispersion, it actually causes the light pulses to spread out and eventually smear together.
Oh, so that's why the signal degrades and taps out at 500 feet.
Exactly. Single mode, however, uses a highly focused laser shooting straight down a microscopic core. No bouncing means no smearing.
Which allows the raw data pulses to travel cleanly 4 miles.
Wow.
So it's a completely different transport mechanism depending on the mode you use.
Right. And if you look at HDTVSupply's vendor profile, they are outfitting massive sports bars, casinos, and live venues, places running up to 160 displays.
That is just massive.
It really is. And in an environment like that, distance actually isn't the only enemy. Standard copper wiring acts like a giant antenna for electromagnetic interference, or EMI.
Oh, right, because you're running copper cables through a ceiling packed with, what, high voltage lighting, industrial HVAC units, and just hundreds of other wires.
Yeah, all of it. That electrical noise will absolutely scramble your data. But because this transmitter converts the USB data into photons instead of electrons, the signal becomes completely immune to that EMI.
So you could literally wrap the fiber cable around a humming industrial generator and the data wouldn't flinch.
Exactly.
Which explains the physical design of the unit itself. Like, it features a bus-powered local unit, a remote power adapter, and it's rated to operate in ambient temperatures up to 131 degrees Fahrenheit.
Yeah, and that heat tolerance is a real giveaway regarding who this is actually for. I mean, this gear isn't sitting on a climate-controlled office desk.
Definitely not.
It is getting shoved into an unventilated electrical closet in the rafters of a sweltering arena in the dead of summer.
Which brings us back to the price tag.
Right. You are paying that $594.15 for industrial-grade reliability because a system failure during a live event costs substantially more than the hardware itself.
Yeah, it's essentially a spatial illusion. The hardware takes 4 standard peripherals plugged into its integrated hub and tricks the host computer into thinking they are attached directly to the motherboard.
Even if they are physically sitting in the next zip code, it creates a perfectly synchronized ghost connection.
Just doing all the heavy lifting in extreme conditions without adding a millisecond of lag to the overall system.
Exactly.
Which, brings up a completely different aspect of beaming uncompressed data over vast physical distances.
What do you mean?
Well, if a device like this is transmitting unencrypted, raw peripheral inputs like keyboard strokes, badge scanners, or security camera feeds 6 miles down a single strand of glass, what actually happens if someone manages to physically tack that optical line?
Oh, wow. That is a terrifying thought.
Right. Think about the vulnerability of the miles of invisible infrastructure connecting our devices long after the data leaves the safety of the server room. Just something for you to ponder next time you are at a massive venue. Thanks for joining us on this deep dive.